Welcome to Concurrency Café, a place where baristas are always busy, just like threads in your C# application. But just like in any chaotic environment, these can get out of control if there is no proper management and control. And in C#, that is exactly where synchronization and thread safety come to the rescue. Without proper synchronization, threads can collide, they can cause data manipulations in the same memory location, or even worse, they can create deadlocks, bringing your entire application to a grinding halt. So, in order for you not to encounter these problems, this video will be dedicated to sharing experience and understanding core concepts of synchronization and thread safety, so you never end up in the problematic situation that we just mentioned. Greetings, dear friends, fellow programmers, and those aspiring to be. Welcome back to Marco Code Academy, a place where we are learning about mechanisms while being thread safe. I do not want to waste any more of your time. We're going to jump into the mechanisms right away. Thread safety is exactly like ground rules of a very busy cafe. It ensures that multiple threads can work concurrently without interfering with each other's work and breaking the memory consistency in the process. But how do we enforce these rules in a multi-threaded environment? Because the main challenge of multi-threaded environment is the fact that within a single process, we have a shared memory space that is being shared across all the threads that are inside of that process. Meaning that your process is your application practically, and threads inside of that application are all using the same memory space. And that also can bring a lot of issues because multiple threads can read or write from the same memory location. This can lead to race conditions, which means that basically what will end up being in the memory location depends just on which thread completes its task first and which completes its task last, which is really not what we want in our code. We want to have code that always has consistent results without anything affecting those results. And in this scenario that I just explained, basically time of execution decides what is going to be inside of a certain memory location, which is a big no-no. And this, my friend, is exactly where synchronization mechanisms come to the rescue. Okay, we need to get started from the simplest mechanism for synchronization in C#. I'm talking about lock mechanism. It is basically like each barista in the coffee shop has its own key to unlock the coffee maker, and only a single person can plug their key into the coffee machine and then use it. Meaning that once I'm using the coffee machine, no other barista can use it because I plugged in my key and I'm the person using it. When we translate this into C# terminology, this means that when a single thread locks a certain resource, no other thread can access or manipulate that resource in any way until the first thread is done doing its job on that resource. Once it is done, it will unlock the resource for other threads to again be able to access it. But while it's working on it, none shall pass. Of course, this simple mechanism prevents race conditions, that way ensuring that data on the resource that was locked stays consistent. But of course, nothing in life is perfect. If this mechanism would work as a charm and there would be no issues when working with it, we would not basically need anything else except locks. But we still do have different mechanisms, which means that locks do have their own limitations, which are the problem with deadlocks. Now, what are deadlocks? When we go back to our example with Café and baristas, let us imagine the scenario where we have two baristas who plug their keys into two different coffee machines. The first barista uses the first machine to start making their coffee, and the second barista is using the second machine to prepare some part of the coffee making process. But the second barista needs to go to the first machine in order to finish their coffee making, and the first barista needs to go to the second machine to finish their making. And both of the machines are locked because they're being used at the moment. But none of them can be unlocked because none of the tasks are complete. None of the coffees are completely made, which means that those two machines are completely off limits because they're completely frozen and stuck in the moment without any way to get unstuck. This process of ending up with multiple threads locking multiple resources which are needed by other threads in order to complete their task means that our application will be blocked from executing and basically it will just crash. That concept is called deadlock. Well, if we cannot make things work perfectly without any issues when we are just using locks, we need a manager in our coffee house. A person who will sit there, watch what baristas are doing, and when they get to a situation that they're stuck or they reach the deadlock, the manager is going to be the one to say, hey, plug out your key, you plug out your key, and then switch your coffee makers. And basically, that is how monitors work in C#, meaning that monitor is going to not only lock the resource, but also behave as a manager who is going to coordinate how threads are working with resources and how they're locking them, meaning that monitors will provide us with more control when compared to locks. And the way how this concept works is that basically monitor is going to observe when the resource that a single thread is waiting for and is at the moment locking a certain piece of resources, when the resource that is needed next gets free, the thread unlocks its lock from the resource it was using, it attaches itself to the resource it needs, it finalizes the work it needed there, and then it goes back to the resource it needs to finalize its work, locks it again, and there you have it. None of the resources are being deadlocked. They are locked, unlocked, locked again, and finish the work. Meaning that threads will not waste time waiting for a certain resource to be unlocked. They will just do the work they can. When the resource they need gets freed up, they will use it and come back to execution in their own resource. But in the meanwhile, their initial resource gets released. Basically, by using monitor lock and monitor pulse methods, we have more fine-grained and more complicated but better and smarter way to manage our threads in a multi-threaded environment, leading to better resource utilization and thread organization. Sometimes even monitors are not good enough of a solution. So you want to have control over who can access a certain resource. Or if we go back to our Café example, that means that we need a way to decide which barista can access which coffee maker. Maybe some baristas do not know how to operate some coffee makers, which is where Mutexes and Semaphores come to the rescue. A mutex is like a bouncer at the entrance to our Café who makes sure that only a single barista can operate a single coffee maker, meaning that only a single thread can access a certain resource at a given moment, even across multiple processes. So we're not limited to just the current process, but generally in the entire computer that you are working with, no processes can access the memory that was locked and blocked by the mutex. It's basically more robust version of locks. It ensures system-wide protection and prevents memory corruption across the entire operating system, not the same way as locks prevent access only from the current process. On the other hand, semaphores are working in a way that limits the number of baristas that can work at the same time in a cafe. It basically allows multiple threads to access limited resources in our application. Basically like a limited number of seats in a cafe, which translates to when all resources are in use, no threads can basically touch those resources. And those threads that have nothing to do must wait for resources to get freed up before they can pick up anything. Basically, semaphores are very useful when you have very limited amount of resources that you want to share across limited number of threads. And this entire concept, of course, prevents overloading your resources with more than enough threads and basically limiting the chances that those threads are going to use and corrupt memory locations, or how we call them, resources, by having too many threads in the limited resource space. Sadly, not all synchronization problems can be solved with mechanisms we covered. Sometimes we just need to ensure that data is visible and not corrupt across all threads. And the easiest way to ensure that that is true, we just need to make a copy of a memory location that will be assigned to a certain thread. And this is where volatile keyword and Thread-Local Storage come to the rescue. A volatile keyword makes sure that value of a certain variable always gets read from the memory location that is not thread-local memory location. That basically guarantees that changes that were made by a certain thread are immediately visible to all other threads. That way, we're preventing bugs that come out of the fact that some data might be outdated or corrupt. If we use this approach with volatile, we will not end up in that situation for sure. And now we need to discuss thread-local storage. Now, as I mentioned already, we can create copies of the memory space for each of our threads. That way, our thread will have its own copy of the memory space that it can work on itself and like completely privately without any other threads interfering with that. And when it is done performing actions, it can just update the memory location that is publicly available, not its thread-local storage. This is of course very useful when you need to make sure that your thread is working with its own private piece of memory space where no other threads can interfere with the mid-steps in the calculation process. So, if you enjoyed this video and would not like to miss out on those concrete examples, please feel free to subscribe to the channel, because that is the best way to make sure that you will not miss out on them. And trust me, you do not want to miss out on understanding these important concepts. So, until the next video, thank you for watching and have an amazing day.